Hello, welcome. In this video, we will look at a case study, the 9-tail problem. So here's the 9-tail problem. We have 9 coins are placed in a 3x3 matrix with some face up and some face down. So this is the head and this is the tail. A legal move is to take any coin that is face up. So this is the or this head, and reverse it. When you reverse it together, and the adjacent cells will be also reversed. So when you flip this H, you're going to flip and this H and this T2. So I'm going to flip this H now, and this will become T, T, H. So I'm going to flip this, and that's what you see here. And now I'm going to flip this H, so everything becomes T. So that is what we need to look at. The objective is to have the minimum number of flips to get all the coins to become the tail. So you can try it, and if we get another random state, and you can try to flip all this, and so it is not easy to get a solution, and we need to write a program to examine it systematically. We'll write a program. The program prompts the user to enter the initial state of the 9 coins. So we put this as a string here, H, H, H. So that's the first row, and this is the second row, T, 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 and this is the third row, H, H, H. Now that's the input. And so here are the steps. So this is the one, initial one, and now we flip this this right here, and the flip this one right here, and so that's flip this, and we're getting this, and now we're gonna flip this H, and we get this, all the T's. How do we write this program? We're going to use graph to model this problem and reduce the problem to the breadth first search to find the shortest path. To reduce the problem to graph problem, we're going to have this 5, 12 vertices. Each vertex represents a state. So this is all the head. This is the one here. You have, this is the tail, and this is the tail. So this is the tail, tail. So 0 is the head, and 1 is the tail. There are total 512 states. Each state is a vertex. And now we're going to create the edges. So the edges is this. We're going to create a directed edge here. So now you from here, so this is the 0, 0, 0, and 1, 1, 1, and 0, 0, 0. So this is the state. Now please note that I also put the number here. It's a 56. You can actually use 56 to represent this. This is the 9 binary digits, and decimal is 56. So that's much easier than using the binary. So here's 56. So if you flip, so you're gonna flip this here, 0, head, and you're going to get this one right here. So we're going to have age from 48 to 56. Now, if you flip the one and here in the middle, and so you're going to have this 1, 1, this is 0, and that is this 4, 8, 8. So we're going to draw age from here to here. And now from this 4, 8, 8, if you flip this 0, you're going to get to this 1 right here, and this is going to be 1, 1, 1. So 1, 1, 1. And we're going to draw the age from this. This is the final one. It's the target. It's the destination. This is what we want. From this 5, 11 to 4, 8, 8. Now, if you draw this and all these ages, and with this 512 vertices, you build this graph. And from this graph, you're going to find the shortest path, and starting from this this 511, this vertex 511. So if you want to say here, I want to find the shortest path from 511 to this, and so here, this is either this or this two. So we're going to have this 9-tail model. So to model this problem, in this 9-tail model, we're going to build the graph with the vertices and edges. And from here, we're going to create this breadth first tree starting from the destination and node. This with all the tails. That's 511. And here you get the shortest path and for a vertex at the specified index. So this is the 9-tail model. And the 9-tail model here, we're going to have this is the total number of vertices, number of nodes here. It's 512. And this is the init method. So we get all the edges. And now this is all the vertices we have. So we're going to just use number 0, 1, 2 to 512. And for all the vertices, creating the graph using the vertices and edges, and get the breadth first tree starting from this vertex 511. And this is the shortest path for any vertex and to 511. So these are the supporting methods for this model. And now, let's write this code here for the 9-tail. So for 9-tail, we're going to have build the model. So this is 9-tail model. So we get the input, and this is 9-tail model. And now we get the path for this. This is the initial node. And so we get the index for the initial node in the graph and get the shortest path. And this is the path. And we're going to print and this node. That is all for this video on the case study of the 9-tail problem. We solved the problem by creating a graph model and using the breadth first search to find the shortest path. Thank you for watching. See you on the next chapter.